Hello, everyone. Let's go over the ladder paradox. Imagine this scenario where you have a barn that's 10 meters wide, and there are two observers. One observer is stationary and watching the barn from a distance, while the other observer is carrying a ladder that's 12 meters long and running the barn at a very fast speed, let's say 90% the speed of light. So we ask the question, does the ladder fit inside the barn? Classically, we would think it does not, as the ladder is 12 meters long while the barn is only 10 meters long. But with relativity, the objects undergo length contraction, which would make the object smaller. In the reference frame of the observer holding the ladder, they would be stationary while the barn appears to be moving, causing the barn to have a contracted length, which results in the ladder not fitting inside the barn according to the perspective of the person carrying the ladder. But to the stationary observer, the ladder would appear to have a contracted length instead, since they observe the barn to be at rest while the ladder is moving in the direction of the barn. As such, the stationary observer sees that the ladder fits inside the barn because of length contraction. So the ladder paradox asks, which observer is correct? The observer with the ladder says it does not fit inside the barn, while the stationary observer says the ladder does, in fact, fit inside the barn. Well, it turns out that they are both correct. And this is because simultaneity is relative, so then the observers disagree because they did, in fact, experience different versions of this scenario. While the stationary observer saw the ladder fit inside the barn, the observer with the ladder did not experience these events simultaneously, and as such, they saw that the ladder did not fit inside the barn. So both observers are correct.